On October 9th, 2022, Earth was hit. Not by an asteroid, not by a solar flare, by a gamma-ray burst, the most energetic explosion in the observable universe, from a star that died 1.9 billion light-years away. For 800 seconds, gamma radiation from that explosion hammered Earth's ionosphere. Lightning detectors in India activated. Instruments in Germany registered ionospheric disturbance for several hours. The burst was 70 times brighter than any gamma-ray burst ever previously recorded. And here's what nobody told you. There was no warning. Not a second. Not a millisecond. The warning and the event arrived at the same time. Because that's what makes gamma-ray bursts different from every other threat in the universe. Everything else gives you time. This doesn't. A gamma-ray burst releases more energy in 10 seconds than the sun will emit across its entire 10 billion-year lifetime. The October 2022 burst, GRB 221009A, was classified as the brightest of all time, the boat. Statistically, a gamma-ray burst this powerful arrives at Earth once every 10,000 years. It hit us from 1.9 billion light-years away and still disturbed our atmosphere. The question isn't whether one could reach us from close enough to matter. The question is whether one already has. The answer to that question is 440 million years old, and the evidence is written in the fossil record. The late Ordovician mass extinction, 440 million years ago, killed approximately 85% of all species on Earth. It is the second largest mass extinction in the history of life. For decades, the cause was debated. Climate shift, glaciation, sea level change. Then, in 2004, Millet and colleagues published in the International Journal of Astrobiology a different explanation. The extinction pattern didn't match climate. It matched a gamma-ray burst. Organisms in deep water survived at higher rates than organisms near the surface because water absorbs ultraviolet radiation. Organisms in shallow water and at the surface, where UV exposure would be highest after ozone depletion, died in the highest numbers. The pattern of who survived and who didn't maps almost exactly onto what a nearby gamma-ray burst would produce, which means the mechanism that could end life on Earth may not be theoretical. It may have already run once. Here's the detail that separates gamma-ray bursts from every other existential threat. An asteroid. You can see it coming. Months. Years. Decades of tracking. Apophis has been on the calendar since 2004. A solar flare. You get 8 minutes from the moment it leaves the sun to the moment it hits Earth. 8 minutes is long enough to shut down satellites and power grids. A gamma-ray burst gives you nothing. Gamma rays travel at the speed of light, which means the warning and the burst itself arrive at exactly the same moment. There is no early warning system that could ever exist for this threat. Not because we haven't built one, because physics doesn't allow one. The moment you detect a gamma-ray burst, it has already hit you. And what it does in that moment, in just 10 seconds, is what makes the physics genuinely irreversible. A long-duration gamma-ray burst lasts between 2 seconds and several minutes. The energy arrives as two focused beams, relativistic jets launching from the poles of a collapsing massive star at nearly the speed of light. Those jets are narrow, between 2 and 20 degrees wide, which is why most gamma-ray bursts never affect Earth. The beam misses us entirely. The universe is vast. The beams are narrow. Most of the time, we are not in the way. But the math changes when you consider the numbers. The observable universe contains an estimated 2 trillion galaxies. Each large galaxy contains hundreds of billions of stars. Long-duration gamma-ray bursts occur at a rate of roughly 1 per galaxy per million years. That means across the observable universe. Gamma-ray bursts are happening at a rate of approximately 1 per second, right now, while you're listening to this. Somewhere in the observable universe, a star is collapsing. 2 jets of pure gamma radiation are launching at nearly the speed of light. One of them is aimed somewhere. We have no way of knowing which direction that somewhere is. Now consider what happens if one of those beams is aimed here. A gamma-ray burst within 6,000 light-years of Earth, pointed directly at us, would deplete Earth's ozone layer by 30 to 50% globally. Local pockets over 50%. The ozone holes caused by human activity represent depletions of less than 5%. This would be 10 times that, in 10 seconds. Ultraviolet radiation from the sun, normally blocked by the ozone layer, would reach the surface at levels lethal to most surface life. Recovery time for the ozone layer, years, possibly decades. The gamma rays would also break apart nitrogen molecules in the atmosphere, reforming them as nitrogen dioxide, a reddish-brown gas that would reduce visible sunlight reaching the surface, cool the Earth, and rain down as nitric acid. The cooling effect alone matches the climate signature of the late Ordovician extinction, the one where 85% of species died. A single 10-second event, no warning. Ozone depleted, UV radiation lethal, cooling triggered, acid rain. The sequence that followed the second largest mass extinction in Earth's history, all of it, triggered in the duration of a phone call. And right now, there is a star 8,000 light years from Earth that is preparing to do exactly this. WR-104, nicknamed the Death Star, a Wolf-Rayet star, the final evolutionary stage before a massive star explodes as a supernova. When a Wolf-Rayet star explodes, if it's spinning fast enough, it doesn't just expand outward. It launches two focused jets of gamma radiation along its rotational poles. For years, models of WR-104 suggested its rotational poles were pointed directly at Earth. In March 2025, a study published in the Monthly Notices of the Royal Astronomical Society by Grant Hill of Keck Observatory revised that angle to 30 to 40 degrees, meaning the burst would likely miss us. Likely. Not confirmed. Not certain. Likely. And the distance to WR-104 is still uncertain. Estimates range from 5,000 to 11,000 light years. At the lower end of that range, if WR-104 is 5,000 light years away and its axis is closer to Earth than the 2025 study suggests, the calculation changes. Not dramatically, not to certainty, but enough that WR-104 is still being watched, still being measured, still being debated in peer-reviewed journals as recently as 2025. In October 2025, AAS Science reported a long-lived gamma-ray burst that puzzled astronomers. It lasted far longer than any existing model predicted, suggesting a new category of gamma-ray burst that current science doesn't fully account for. A new kind of cosmic catastrophe, still being characterized, still not fully understood. The October 2022 BATE, GRB 221009A, was detected by every major gamma-ray observatory in orbit. It saturated almost all gamma-ray detectors simultaneously, meaning instruments designed to measure these events couldn't measure this one. It was too bright. The brightest gamma-ray burst ever recorded was too bright for the instruments built to record it, from 1.9 billion light years away. Now consider the rate. A dangerously close gamma-ray burst, within the range needed to affect Earth's ozone layer, is estimated to occur on average 2 or more times per billion years. Earth is 4.5 billion years old, which means statistically, it has happened at least 8 or 9 times in Earth's history. We have identified one possible event, the Ordovician. The others, if they occurred, left signatures we either haven't found or haven't recognized. And in all of those events, across 4.5 billion years, there was no warning. Not for the organisms living through it. Not a second. The only thing that has ever protected Earth from a gamma-ray burst is geometry. The beam has to be pointed here. Right now, we have no confirmed beam aimed at us. But we also have no way of knowing about the ones we can't yet see. The stars in distant galaxies that are collapsing right now, whose beams are traveling toward us at the speed of light, and will arrive with no warning at all. The most powerful explosions in the universe last 10 seconds. They travel at the speed of light. They arrive without warning. They strip ozone from an entire planet before the planet knows they're coming. One of them hit Earth in 2022 from 1.9 billion light years away. We still don't know how many have hit us that we haven't recognized. There's no early warning system. Not because we haven't built one, because the warning is the event. Like if you'll never look at a clear sky the same way. Subscribe to Star Dread, new cosmic horror documentary every day. Tag someone who thinks space threats come with warnings. What should terrify you next? Drop it in the comments.